when we were finding in 7.1 confidence intervals for proportions, we had this point estimate. And this was the biggest question people had, but I think it was really just a vocabulary question, because once I told you what it was, you're like, oh, I have that. What is the point estimate? P hat is what I'm hearing. What does P hat represent in words? Not quite the mean, but it's similar to that.
Most likely point
Most likely point, like where's it come from though?
between the
It's the middle of the time.
Sample, it's in the middle of the confidence interval. But if I was gonna use you guys as my sample to estimate the proportion of people who love statistics, how would I find P hat if you guys were my sample? I wouldn't find the mean because you're asking, basically you're giving me a yes or no answer. So I can't find the mean of yeses and nos. Say that 5 of the 30 of you told me you like statistics.
Should be 5 divided by 3.
Aha, 5 divided by 30, your P hat is just your sample proportion. You put that right here. That's your sample proportion. The probability or the percent or the proportion from your sample. So in my example I just made up, if 5 out of 30 of you like statistics, then P hat would have been 5 out of 30. Turn that into a decimal. If you want to make it into a decimal, it'll be 0.167. It turns out that that is also the number right in the middle of your confidence interval, because remember you took your P hat and you added an error and you subtracted the error. Just make sure that you understand what P hat represents. It comes from your sample, excuse me, and from there we add a little bit, subtract a little bit to get our interval. The reason I'm really beating that up right now is the point estimate where it's going to come up again in 7.2 and in 7.3, and you need to know that it's the information that you get from your sample. Questions on that? So a lot of you tried to use the word mean in that example I just did. That's exactly what we're going to do in 7.2. Let's say I wanted to find the average GPA of LMC students. And I decided that you guys were going to be my sample. And I'm going to then use that to predict what it is for all LMC students. And if I want to find the average GPA, what would I do with you guys? How would I find what would I use to estimate what it might be for the whole population?
All of our GPAs.
Take all your GPAs, and what would I do with them? Average them. I'd actually find the mean from this group, and then I would use that to guess what it is for the big group, the whole LMC population. Well, how do I write that I want to find the mean for a sample? P hat was a proportion. Now we really are talking means. What symbol have we been using almost all semester to represent the sample mean? X bar. Remember X bar? So this was the sample proportion. So what we're going to do today is we're going to find a new point estimate of X bar. Let's talk about how it's different. They're both point estimates. One is I'm trying to get a percentage of people who like stats, a percentage of people who fall into some category. That's not a mean, that's a percentage or a proportion. So I would say, oh, 5 out of 30 of you, and then I would estimate and get a range of values for that proportion. But if I'm trying to estimate a mean, then of course I would use a mean as my estimate. Guess what I'm going to use if I want to do a standard deviation? What would I find to estimate a standard deviation from a sample? Sigma's for the whole population, so what was it for the sample? What letter did we use for the standard deviation? S, or SX on your calculator? So depending on what the question's asking, you're going to see lots of questions on the exam next week that say, find the confidence interval for. If it says find a confidence interval for a proportion or a percentage, then you're using P hat and doing what we did last time. If it says find a confidence interval to estimate the mean, then you're doing X bar. And if it says estimate the standard deviation, then you're using S. And no matter what, you're taking the information from your sample and then getting a range to estimate it for your population. There's 3 types of confidence intervals you'll be asked to find. Did I see your hand in there?
So for the point estimate, is it X divided by N?
It would be, yeah, it'd be, well, it's not a proportion anymore. It would be actually finding the mean. If you're talking about for the mean problem? Oh, for this one, yes.
Yeah.
The sample proportion is X divided by N if you're doing a proportion, yes. And this also comes right up, when you did the one prop z int on your calculator, it even handed you p hat. You didn't even have to divide them, it did it for you. So I'm going to show you something on your stats handout before we go any further. Anybody need one today? I think you're getting good at listening to me when I ask you to bring them every day. On the front page, this one's all scribbled over. On the front page in the upper right-hand corner, right, yes. Upper right-hand corner up here, front page. Notice what it says up there? Upper right-hand corner, confidence intervals. Confidence intervals using one sample, which is all we've done so far, one sample at a time. The very first box up there is if you're looking for a confidence interval for a proportion. There's that scary looking formula that we did once. But underneath that, notice it says one prop z int. So if the problem says find the confidence interval for a proportion, that's what we were doing in 7.1. Everyone okay? That should look familiar. Look at the next box down. If you're trying the confidence interval for a mean, there's some other stuff in there. Notice now there's x bars and mu's in their formulas. We're going to talk about that in a second. And then there's different calculator functions, which we're also going to mention. But then if you look at the next box down, it's a confidence interval for a standard deviation. So remember I was just saying there's 3 different types of confidence intervals, 3 different methods of how to get them. You have this on the exam, so the important thing is to read the question. What kind of confidence interval am I being asked for? And then we'll know how to attack it. Okay, another thing I wanted to point out on this, which I didn't mention last time, is remember we were finding critical values? We're about to find critical values again. We were finding critical values, like z alpha over 2 for a 90% confidence interval or for a 96% confidence interval. And we mostly did inverse norm to find those. Brian likes to use the table. We did that also to find in critical values. Look from the normal pages 4 and 5, particularly page 5. In the lower right-hand corner of page 5. Lower right-hand corner of page 5. What are those? Critical values for specific confidence levels. And there's 90, 95, and 99, which are the most common ones. So next time you need to look up a critical value, you don't have to do inverse norm every single time, because what happens is we do it so often for 90, 95, and 99, those are just written there that you can just go look on the bottom of that page and get them. Now, if it's a 96%, it's not there, so you still have to draw your picture and do inverse norm. But a lot of times your critical values are right there when you're looking for your z's. Everyone okay with those? All right, so let's move on to 7.2. 7.2 is on page 94 of our notes. And notice what it says up there. Estimating a population mean. What were we doing last time in 7.1? I heard it very quietly, I think somewhere over there. Is that you, Evelyn? We were estimating a population proportion. What's the difference between a proportion and a mean?
Means for a sample?
Oh, we can find a mean for a sample and a proportion for a sample. We actually talked about that here. We can find a sample proportion and a mean for a sample. You guys you just finished your projects. What kind of numbers or values or variables did you have where you had to find a mean? Anybody? When would you find a mean versus when would you find a proportion? Okay, let me ask you a question. What's your favorite color? Uh-oh, we can't even answer that one. Anybody? Nobody has a favorite color?
Green, like purple.
Purple? Green, I heard? Blue? What kind of variable is that? Categorical. You guys are all giving me categories. Would it make sense for me to find the mean color? The average color? Take all the blues, yellows, purples, greens and add them up?
Is it quantitative data?
Yeah, how do you, that's not quantitative data. I can't find the mean for categorical, can I? So the mean only works for quantitative. We're waking up this morning, this is good, thank you, Brad. Helps with making sure everybody else is getting there. Everyone said we can't take the mean of green and purple and blue? What do? Orange and a half. I don't know how to find the average there. But if I said what percent of you like green, I could find a proportion. A proportion and a percent are the same thing. I would just count how many people chose green out of the total. And essentially I'd be doing something like this again. So a proportion is when you have categorical variables and you're trying to figure out what percent or proportion fall into that category. But a mean is when you actually have quantitative data, like Brian says, and we add them all up and divide by however many we have. So we're estimating a mean in this case. Last time it was proportions. The problem will always tell you which one you're estimating, and it won't make sense to talk about one versus the other. Okay, there's two techniques for finding your confidence interval for a mean. It depends on whether or not you know sigma. Very top of page 94, underneath the definition, or the title there for 7.2, it says if sigma is known. You see where that is, if sigma is known? That's going to apply to this entire front page. When we get to the next page, it's going to be what happens if you don't know sigma. So if we know sigma, we're going to keep going here. We have to have these normal requirements. You either have a large enough sample, bigger than 30, or you already know your population is normally distributed. So those are your requirements to be able to use this, which has pretty much been our requirements for everything. And then look at what it says to find the confidence interval. The very first thing it says there, it says confidence interval x bar plus or minus e. That should look very familiar. What's it look like? Thank you, the one we just did last class, but what did we do last class? It was p hat plus or minus e. Better pen. This was last time. That's what we're doing now. Last time we were estimating a proportion, so we started with a sample proportion and then added and subtracted to get our error. This time we're taking a mean and adding and subtracting to get our error. So it's very similar, but there's a subtle difference. That's the only subtle difference here. Basis bottom ones, we're not working on that now. And then next to that, we have this, x bar minus e less than mu less than x bar plus e. What is that telling me? Yeah, it's actually writing it in interval form. This is similar to what we did last time, but what did we have in the middle last time? It wasn't a p hat, which is p, because we were estimating the population proportion. What does mu represent? The mean for the population. So you're going to get a range of values that include your population mean. So last time we were getting a range of values that include the population proportion. Now we're going to get a range that gives us our mean. So I think it was Evelyn last time said, do we have to write it with the p in the middle? This is exactly why it matters if you put the p in the middle, because p and mu are not the same. We need to know which one you're estimating. So that's how we write it. And there's two methods. Method one is we calculate using the formula to get our e, and we add and subtract it just like we did last time. You guys loved the formula last time, I remember that. And our other method is we just go ahead and we use our calculator. I am fine with using our calculator. And so we're going to just do that. It says the margin, how to find the margin of error. You don't need to find it by hand if you have a calculator. So notice what it says here. It says we're going to use z interval. We use z interval when you're trying to estimate the mean and if you know sigma. We're going to talk a little bit later about how you know it and how you don't know it. Look back over here again. Remember, this is your best friend that you're bringing to your exam. The second box down, it has mean. Has the same notation I just wrote with x bar plus and minus the e. And look what it says. If sigma is known, use the interval. You see that? So if you forget what to do, it's always right here. The important thing is you have to know what the question's asking, otherwise you don't know where to look. All right, so let's look at example 1. We have randomly selected stat students. They participated in an experiment to test their ability to determine when 1 minute had passed, 60 seconds. So we said, okay, go, tell me when to stop, without looking at the clock, to try to estimate if we know how long a minute is. And so there were 40 students. They had a sample mean of 58.3 seconds. Assume that sigma equals 9.5. Construct a 95% confidence interval estimate of the population mean of all stat students. So first off, talk to me about what's been given to us.
The sample mean,
The sample mean, so how do I write the sample mean? What's my notation for that?
X bar.
X bar. So the sample mean was given to us, that's X bar. Where'd it go? 58.3?
Would N be the 60 seconds?
N would not be the 60 seconds. What does N represent in words?
the students.
The sample size, the number of students in this case. So how many students were there? 40, so that'd be your N. The 60 seconds is, we were trying to get them to estimate 60 seconds. That's actually extra information. But there were 40 students that were sampled. And what else did they give me? Standard deviation of
9.5.
9.5, but what standard deviation did they give me specifically? The population. How do I know it's the population standard deviation?
Sigma.
It's a sigma. What would it have been if it was the sample standard deviation?
NS.
An S. Thank you. Really important. This is the day where knowing the difference between sigma and S and X bar and mu is so crucial, because the approach you take to solve the problem changes based on what you have. So this was everything that was given, and they asked me to find what? Construct what? Construct, didn't say find. Construct a 95% confidence interval, and keep reading after it says confidence interval. 95% confidence interval estimate of the population mean. Underline that part that says population mean, because the problems you just did last time said construct a 95% confidence interval for a population proportion. And the one different word changes the whole thing on how you're going to approach that. Population mean. So let's say this problem's on the exam next week. I read the directions, I start panicking. I don't know how to do this. I pick up my little guide here. I'm like, oh, I'm asking for a confidence interval, so I'm going to look up here. It's not a confidence interval for a proportion, so I don't want to look at that one. It's a confidence interval for a mean. So, okay, I know which box I'm in now. And then this talks about z interval and t interval, which we haven't done t interval yet. But if sigma is known, we use z interval. Luckily, we know sigma, so we're going to use z interval. So we're going to go into stat and test and find z interval now. Let's see if we can find it. Stat test z interval. Tell me what it asks you for. First we have to see if we can get that page to come up.
The first thing it says data stats.
It says data or stats. I'm glad you pointed that out. Data would be if, instead of having the sample mean, if I just had the list of everybody's times. She said 52 seconds, you said 74 seconds, she said 38. If I had the list, that would be the data, if I actually had typed it all into a list. I don't have that at this point. So we have the stats. The stats is the summary. So we'd leave it on stats. But there could be a problem. There might be one coming up. Well, there is, where they give us the data. So data is when you actually have your list of data, and stats is when you have just the stats. So we'll leave it on stats, and then what does it want from us?
Sigma.
It wants sigma, which we know. So here's what you'd write on your exam, by the way, or your quiz if you're taking a quiz. You would tell me that you're doing z interval, so I know where you're going on your calculator. you would tell me what you're typing in for everything. So you would type in sigma equals 9.5, what's next?
X bar,
X bar, you tell me what you typed in there.
and N and C level.
And N is 40, and then the sea level, what do we put for sea level?
0.95.
0.95, has to be in decimal form. Is that all it asks for?
Mhm.
And then it gives you the option of drawing it, doesn't it? Does it say draw? Or does it say calculate?
Just calculate.
Just calculate, okay, good. The other one says draw. So then when we calculate it, it gives you, just like last time, it gives you a range with two numbers in parentheses. What do we get?
55.356
Uh-huh.
and 61.244.
We agree with Phoebe's numbers?
Yeah.
What are those numbers?
Those are tails?
Those are kind of like our tails. That's what cuts off our tails. Those are the edges of our confidence interval. But what does that have to do with people guessing how much time has gone by?
That's the range?
Go ahead, Hannah.
Oh, isn't that like between not the estimate, but between the numbers?
Between these two numbers, she called it the range. What's between those two numbers?
And then in between is the mean.
The mean. Remember, we're estimating the population mean? And what's the symbol for population mean?
X bar.
Ooh, population mean, careful. Symbol for population mean is mu. So what we're going to say is mu is between these two numbers. This is my confidence interval. Let's talk about what we just did. We took a sample of students. They had 58.3 seconds average for how long is okay, go, how long you think it is till it's been a minute. What we've done now is we've estimated what it would be for the whole population of all students. All students would have a mean somewhere between 55 and 61 seconds. Questions on that? What if the problem had asked you to find the point estimate? Since that was the question I kept getting last time. The point estimate.
You just add those together and divide, right?
We could add them together and divide by 2 to see what's in the middle. I claim we actually already know that number
So
though.
next number down, on your calculator.
Your calculator actually tells you X bar if you're looking at the screen underneath there. So X bar, or you also already had it right here. We had X bar. The point estimate this time is X bar because we're estimating a mean. What if they had asked you to find the margin of error?
Subtract.
Yeah, subtract the edges from the mean, just like last time we subtracted the edges from the p. So the same idea for that margin of error. Because a lot of times online they ask it to you in lots of little different, separate little questions to make sure you get all the pieces. Everyone all right on how to find margin of error?
So you would do, like 61.244 minus the 58.
Yes, because if we had drawn a picture for this, the 58.3 would have been our best guess, and then we're adding and subtracting to end up at these averages. Let me just put them over here. So the picture is almost identical to what we were doing last time. So this distance in here is the margin of error still, on either side. This time we're taking the sample mean and adding and subtracting an error instead of a sample proportion and adding and subtracting. But they're going to ask you the same questions. They're going to ask you for point estimates. They're going to ask you for error, margins of error. They're going to ask you for confidence intervals. So a lot of it's the same, but you need to understand the subtle difference. Yes, Brian?
So if we're finding the margin of error, would we not want to round these numbers before finding that?
Yes, usually on my stat lab, it gets a little grouchy if you round and then subtract and round again. So it's usually best to subtract first and then round.
Okay.
Because it might ask you for the confidence interval rounded, but then when you look for your margin of error, it wants you to round somewhere else. I was helping somebody last week actually where it wanted you to round one of them to 2 places. Was it you, Kevin, we were doing it? And then another one to 3 places. Like, wait a minute, we just rounded before. So it's best just to keep them the way they are. And luckily, you have them when it comes out on your calculator. You can write down all the digits that you see there. Yes?
So if you were to write it on a quiz or test, would you want us to write it with that, with the M, or could we do it in parentheses?
really good question, the same question Evelyn asked last time. I want you to write it like this with the M between there, because with parentheses, I don't know if you think P is in there, or M is in there, or sigma is in there. So just like last time I wanted you to write the P in here, now I want the mu to show me that you know you're estimating the population mean. And lucky for you, it's actually on your notes here, which one goes in the middle. If it's a mean, it shows you the mu goes in the middle. And up above, it shows you the P goes in the middle. So it's all on there, on their little packet. Other questions?
So M or the symbol, either one's good?
Well, what do you mean in more than
Yeah,
symbol?
M, but it shows the example, it has the symbol in between.
The mu?
Yeah.
Well, I think that's what she was calling M. This is supposed to be a mu, I just can't write mu as nicely as they can. Is that what you're asking?
Okay.
I think we're saying the same thing. I don't know, where are we not? So it's technically a mu, I just don't have the correct font in my hand. So you can make it look as close to a mu as you want and I'll know what you mean. Other questions? Okay, look at the follow-up question on there, still on example 1. Based on these results, is it likely that their estimates have a mean that is reasonably close to 60 seconds? Why yes? Because 60 is in our interval. The mean could be any number between here and here, and 60 is in there? So yes, because 60 is in our interval. Okay, before we go, excuse me, to example 2, I want to point out one more formula above example 1. The last formula right above example 1 says determining sample size. Those are the ones that we just mentioned a little bit ago. I sent out the email with the details on those for you. Sometimes you're asked to find the sample size in this section as well. It's a different formula because we're estimating x bar, or estimating mu's, excuse me, and using x bar instead of population proportions. Also, I want you to look on here, in the middle of the page. In the middle of the page. Determining sample size. The first 2 formulas up there are actually the ones we did last time, with the p hats and the q hats. The top one's if you use 0.5 for p hat and q hat, that's the one I sent you in the email and posted on Canvas. So pretty much we only use the middle one, and then we put in 0.5 and 0.5 if we don't know p hat. But look what it says, if you're estimating a mean, there's a different formula here. If it's a proportion, you use one formula. If it's a mean, you do the other one. One of the most common mistakes on the exam is I ask you to estimate a sample size, and you try to use the wrong formula. And I'll argue that if you don't have, if you're talking about a mean, it doesn't make sense to try to put in a p hat. You can't talk about the proportion of people who have a GPA. I mean, everybody has one. So make sure you know if it's a proportion or a mean. So that's what example 2 is asking. Example 2 says, how many adults must be randomly selected to estimate the mean FICO credit rating score of working adults in the United States? We want a 95% confidence that the sample mean is within 3 points of the population mean, and the population standard deviation is 68. A lot going on there. Let's talk about what we know as symbols. What do we know? We know standard deviation and we know margin of error. I heard both. Let's start with standard deviation. Standard deviation is, I just lost it, 68. And it says population standard deviation. So that is sigma. So they gave me sigma. And Evelyn says they gave us margin of error. Where is that? Doesn't say margin of error. Yeah, it says they want to estimate sample mean within 3 points. That means it can't be off by any more than 3 points. So they're giving you the error without using the word error. But they don't want to be off by any more than 3 points. So that's E, and be careful. Those are not percentage points. Those are just points. That's just the number 3. Like if I wanted to estimate an age in here, the average age in here, within 3 years, I would say, oh, I think it's somewhere between 24 and 30. And that's 3 away from the middle. So it doesn't have to be a percentage if you're not talking about proportions. Okay, that was given to us? What else is in there? Somebody said something. Who was that?
Confidence interval.
The confidence level. I highly recommend you organize what you know before you even do anything, because otherwise you're just gonna get overwhelmed with details. And what is the question asking us to do?
Find the mean.
Find the mean? I don't know if that's what it's asking us to do. It's referring to finding the mean.
Find how many
The
adults.
confidence.
Find how many adults Ariana's saying. You see that? How many adults must be selected? Now, we're going to do something else once we select them, but do we all agree it says how many adults? So what are they really asking us to find?
N.
N, the sample size. How many people are gonna be in your sample? So the question is really saying, find N, how many adults, to estimate the mean. The only two sample size questions you will be asked is either find N to estimate a proportion, that's what we did last time, or find N to estimate a mean. So now that we read carefully about what it's asking me to do, this actually tells me if it's for a mean, we're gonna use that bottom formula there, which also is the one on this page. Yes, ma'am?
I'm confused on how it's asking for N.
Because it says, how many adults must be selected? Because they're gonna take some people.
Never mind, I was looking at the bottom part.
Oh,
Okay,
you're looking at the wrong one? Okay, yeah, so I'm on example 2. How many, so sometimes it'll be really nice and say, find the sample size. But a lot of times it'll say, how many should be selected, how many people should I interview, how many calculators should I grab out of this box? I mean, the how many is a clue that's looking for the sample size. So we're going to use this formula. Remember that when finding sample size, there are no shortcuts. You have to plug everything into your calculator. There's our formula, typed better on your notes than mine is. Let's break it down so it looks scarier than it is. Let's start at the bottom. Do we have E? Yeah, we have E. Do we have sigma? The only other thing in here is the Z alpha over 2, which is the critical value.
And then 1 minus 0.95.
So we can draw the picture and look it up. Let's draw your memory on how to do that. So if it's a 95% confidence interval, 95 is in between. Evelyn's over here telling me take 1 minus 0.95.
We got it right here in the corner.
And you also have it in the corner. I'm going to point that out again. So let's remind you how to do it. So 0.05 is our alpha, the area on the outside. And then each tail is half of that. That's the alpha over 2. Alpha over 2 is 0.05 over 2. Each of these tails is 0.025. I have 0.025 in each of these. So this number right here, this Z right here, is your critical value that we're looking for. If I hadn't shown you the shortcut when we walked in today, you would have done inverse norm of I'm feeling like you guys have like never seen me before today. The looks on your faces like, I don't know what you're talking about. 0.975. Evelyn's seen me before, I got that. She remembers me. The rest of you look at me like, I don't even know what planet you're from today, Jill.
I had to look at it too.
Okay, if you have to look it up, that's fine. Why don't you just tell me that? Say, hang on, I'm gonna look it up. But you're all looking at me like, huh? We always have to do the area to the left? 0.975 is the area to the left. You can also use your table and look at 0.975. Either way, you're going to end up with that number that's on the lower right-hand corner of page 5. The lower right-hand corner of page 5, because we know the sea level, we know that it is 1.96. It's important that you know how to do it with your calculator or your table though, because sometimes you're going to have confidence intervals that aren't on this bottom corner of the page.
So how do we put that in our calculator
To find this,
now? No.
well, how do we actually do that? Okay, let me
Start
make,
off with the,
yeah, let me make sure everybody has
Okay.
where the 1.96 came from. Questions on where that came from? I'm gonna take silence as meaning we're okay and not that I'm on another planet.
I like how you can infer the inverse norm instead of breaking it down into the 0.025, you just put in there 0.05 divided by 2.
Mhm.
That will give you.
Yeah, you can just type it in there and it'll give it to you.
That's pretty
Mhm. Okay, so now that we have that, we want to find our sample size. So we're going to just plug everything in here. The Z alpha over 2 is the 1.96 that we just found.
does it all have to be in parentheses?
You could put parentheses or you could hit times, it doesn't really matter. Times my sigma, which they gave me was 68, divided by my error, which was 3, and all of that is going to get squared. It's going to be a pretty big number, I think. Tell me what it is before you round it.
1,973.66.
1973.66? Do we agree with her? Folks are still punching buttons. Disagree with her? Or wait,
I got something different.
You got
after
something
the
different?
decimal.
different decimal?
Yeah, the first part is the same, but the after the decimal is different.
What'd you get afterwards?
0.728711.
Could be that I used the whole entire answer for the Z part. I didn't put 1.96.
Ah, okay, that's a good point. So you guys got 728? So let me talk about what just happened here. She says she didn't round this number off, she just left it in there, or whatever came after the 1.96 on her calculator. It was I don't know, let's make it up, 1.96345, whatever. She kept all those digits in here, so that when she plugged it in here, she got a slightly different answer. This is the question that you and I were talking about online this weekend too. If you don't round your Z's to where they want you to, you're gonna get a slightly different answer when you plug it in here. Most of the time we round Z-scores to 2 decimal places. Almost all the time, but there's an exception, especially if you look in this lower right-hand corner. The exception is when it's exactly halfway between 2 on the table. Look at what it is for the 90%. The 90% is 1.645, because it's exactly halfway between the 4.5 and the 4.6. So, or the 4.4 and the 4.5, so they'll put that on there. But on an exam, I don't care. If you wrote it in there the other way with the more digits, and her number's gonna be slightly different than yours, I'm happy that you know what you're doing. I'm not so worried that you round specifically in a different place. When you're online, it gets a little bit crowded though. Usually we'll do 2 decimal places. Is this my answer? I heard it, why not?
We need a whole number.
I need a whole number. We're talking about how many adults to go survey. I'm trying to survey some adults. How many adults should I go survey?
Always round up.
Always round up, because this is a minimum. So I have to go survey 1,974 adults.
So N equals.
N equals, so we're looking for the sample size. So I have to get a pretty big sample if I want to have a narrow margin of error, if I want to have a narrow confidence interval and not be off by much. I better go get a lot of people in my sample. If I sample less people, my margin of error will be wider. The less people, the less precise your answer is. Questions? All right, let's do the third example here. Example 3. We've got medical students all measuring blood pressure of the same person. They obtained the following results. A whole bunch of results there. And assuming that the population standard deviation is 10, construct, those are millimeters. Oh, what's the HG? I'm a chemistry person. I used to know that. I'll look that up.
HG, mercury.
Millimeters of mercury, I think you're right. That makes sense, because the little thing, that's the mercury. So millimeters of mercury, if assuming it's 10, sometimes I just get interested in the weirdest little details that don't matter. We're going to construct a 99% confidence interval estimate for the population mean. So what are we being asked to find? Are we being asked to find the sample size? No. Why? What's it say? What's it want us to do? Find a confidence interval for the population mean. Just like we did over here. Construct a confidence interval for a population mean. You have to know what they're asking you to do, otherwise you have no idea where to start. That's the hardest part of statistics, is reading the question and knowing what they're asking you to do. So how do I find a confidence interval for a mean? Z interval. So I know I want to use Z interval. Let's talk about what we have. We don't have much in this one.
Standard deviation.
We have standard deviation for the population. That was the 10 millimeters of mercury. They gave us standard deviation. And they gave us the sea level. Evelyn's up here saying we have N. They didn't give me N, but can't we find N? Yeah, count how many numbers you have in your list. We could find N by counting. This is all we really have though. Go back and open up Z interval for me again and tell me the first line of what it asks you. We talked about it. Data or stats. See how this one's different? We don't have the stats like we did over there. We actually have a list of data. So we have to tell it we have the data, but we're not actually ready to use it because we actually have to put the data in our calculator first.
So we have two choices when we do these stats or data.
Yes. Either way, we have to get the stats to do the problem, so we're going to have to put it into list 1 anyhow. So we need to put all the data into list 1, or any list that you want, but I'm going to put it in list 1. Put all your data into list 1. Remember way back when, chapter 3, stats, edit.
So we just start there.
Yeah, start there by typing all your numbers into your list. Putting everything into list 1. I'll wait till the clicking dies down. Okay. Now that we have it in there, go back into the Z interval and tell it that you actually have the data. So go over and highlight, hit enter on top of where it says data. Go on top of it and highlight it. It will ask you for something different than it asked last time. If you highlight data, what does it ask for?
The list.
It asks you for the list? Yes, it wants to know where'd you put your data? Can you please tell me? So it asks you for list, and you're going to tell it you put in L1 or L3 or whatever list you typed it into. What else does it ask for? Frequency. Our frequency is always 1. Always. Frequency is 1. It should be already 1 as a default. That means we have 1 of each of those numbers in there.
So we have N, L1, confidence level.
What else does it ask for?
Confidence level.
Confidence level. I think that should be all it asks for.
Yep.
Oh, it didn't ask for sigma?
Yeah.
Oh, it already did?
That's-
You have to put sigma in there somewhere too? Should have asked for sigma.
That's the first thing.
The first thing, okay. So you had to put sigma, I'll put it down here. So we did Z interval, we had to input all this.
Calculate.
Calculate. It's gonna do the whole thing for us. We don't even know what X bar is and we can still do it. When you hit calculate, you should get 2 numbers, which are
127.04.
I got 126.73.
126.03. We need someone to break the tie.
I got 127.04.
Yes, I heard 2 of those. You probably typed one number in wrong somewhere.
I got point.
This seems to be the popular answer, so we're gonna assume that Hannah made a mistake typing a number in, not the rest of us. She could be right though. If you don't have this number, how many people did get this answer? More than half of us. If you don't have this number, you typed one number in wrong somewhere in your list. Put a little note to go check that during the break. What's the number over here?
140.81.
What goes in between here? Mu. Remember, we're estimating the population mean. So we know that the mean blood pressure for this person, of all the people, if all medical students kept taking this person's blood pressure, they'd get really irritated. But eventually, the mean would be somewhere between 127 and 140.
133.
That's your X bar. Yeah, but when we're estimating the population mean, X bar is not part of my answer. The population mean is some number between here and here. That 133 is what it was for that particular sample. That would have been our point estimate. But for the whole population, it's just somewhere in here. We're 95% confident that it's in there somewhere.
That makes sense.
Now, the X bar that they gave you, tell me again what it was, Ken, 133 point something?
1.928.
If you went back into Z interval and told it that you have the stats now, and put this in, you'll get the same answer, right? It's just calculating it for you. Now you do have the stats. So you could do it that way if you wanted, but the point is we've already done it, so. Some people want to go find X bar and always tell it the stats. You'll still get the same answer. Questions on that? When do we do Z interval?
When you know the standard deviation.
When we know the standard deviation for the population, and when the question's asking us to find
Population mean.
a confidence interval for the population mean, not a population proportion. That was something else. Okay, let's go ahead and take a 10-minute break from here, and then when we come back, we'll talk about what to do when we don't know sigma. Oh, yes, ma'am. Go ahead. We'll do after class? Okay. I'm not going to do example 4, but I think you should be able to read it and tell me how to approach it. I want to move on more of the same. So I want you to read example 4, figure out what it's asking for, what you know, what you would do if you wanted to do example 4. So Phoebe's up here saying she thinks they're trying to find n. Do we agree with her? Example 4? We got one person who thinks we're trying to find n. Are you agreeing with her, Brooke? I got 2 people who think we're trying to find n. We've got a couple more people. Example 4 is want to know what they're asking us to find.
How many?
Yeah, how many rainfall amounts, which made her go, yeah. Because it's how many? Now, we're still trying to get an interval eventually, but they're not asking us to get the interval. They're saying how many should we get? How many rainfall amounts? So the most important thing for example 4 is they're asking you to find n. I'm not going to do the whole problem. If they're asking us to find n, though, what do we have? We should have enough information to get what we need. We have the standard deviation for the population.
Sample mean.
We have a sample mean. Do we have a sample mean? No, we don't. We don't have a sample mean. Hang on, I'm reading it going, I don't see it there.
Yeah, it's
No, that's the margin of error.
0.01.
Yeah, what is that 0.01?
The margin of error.
Oh, the margin of error.
It's the margin of error. That 0.01, it says we're taking that sample mean and we want to be within 0.01 of the population mean. That within is how far away you're allowed to go, how close you want to be. So that's the E. 0.01 inches. They want a really skinny confidence interval. To use that formula, which I just erased, to use the n formula, do I have everything I need? I need to find my z, she's telling me over here. I have sigma, I have E. What's the quickest way to find that Z?
Page 11.
Bottom of page 5?
1, 6.
What was the sea level?
0.9.
0.90. So from page 5, what's the critical value? 1.645. Can we plug everything in, round up? Might as well do it now that we're here. Plug it in, round up. What was my sigma? 0.212 divided by 0.1 squared. Yes.
For critical values,
Mm-hmm.
you just, like for the alpha, you just plug in the complement of the sea level, right? So it'd be point 1 divided by 2? and then
Right.
Inverse of that?
Uh-huh.
Okay.
Right. Alpha is the area outside. So if you have 90% in your interval, you've got 10% outside. And then we divide it by 2 because it's half 2 tails, half the half. Yes.
That first part, I don't know what you would call it, the Z.
The critical value.
Critical value, will it ever not be 90, 95, or 90?
Yes.
Oh, well.
So that's when you have to draw the picture and do inverse norm, like we were doing last time. Let me give you a quick reminder. Say it's a 96%, for example. If they were doing a 96% confidence interval, what's the area outside if you have 96 inside? Be 0.04, right? We just might want to minus that. And that 0.04 gets divided by 2. I'd have 2% here and 2% there. Finding this Z right here is inverse norm of everything to your left. Remember it now? So that would have been an inverse norm of 0.98 with 0 and 1. So the nice thing is if it's 90, 95, or 99, you don't have to do any work. But if it's anything else, we can do it. We just have to draw the picture and use inverse norm to get those critical values. Which is why you have those online problems asking you to find those critical values. And the ones on your lab to make sure you get that practice down. So what do we get here? What's the answer?
12.
12? I see some people nodding. 12? No? I don't know. 13? What's the number when you put that in your calculator?
12.162.
12.162? How many people got 12.162?
You got 1,000.
Yeah.
Yes.
I got like 1,000, yeah.
Okay, something's really wrong here.
So the decimal place is after the 6.
Yeah.
Do I have my decimal written in the wrong place?
Yeah.
Yeah, it's supposed to be 1,216.
No, but did I write one up here wrong? 'Cause the way
Your E's wrong.
thank you. See that, guys? I copied my E wrong.
Yeah.
That's why I'm like, 12 makes sense, but not if you copy your number down wrong.
1216.
Can you guys see this?
Yeah.
I copied it wrong right here. Let's fix it.
Thousands.
Which is why you all have the same numbers with your decimals in a different place.
I really messed it up.
It's still the same number. The decimal's over 2 now? What's my sample size? We still round up, because this is a minimum sample size. You can never round down. You can't go below a minimum. So N in this case would be 1217. Good catch. I'm like, why are we getting different numbers? Because some of you are copying the right number down and some of you are following my wrong number. Okay, so let's move on and talk about what if we don't know sigma. Sigma is the population standard deviation. In real life, it's pretty rare that you would know the population standard deviation and have to estimate what the mean is. Like, how would you even know the population standard deviation? Most of the time you can get a standard deviation from your sample only. And that symbol is, sample standard deviation symbol is S. S or SX on our calculator. So a lot of times all we have is S. If we don't know sigma, we use what's called a T interval. It's actually a new distribution. It's no longer normal. It's kind of like normal, but depending on your sample size, it changes a little bit in terms of how tall or how spread out it is. So your critical values will definitely change when you're using T. Can someone pull that door closed, please? Thank you, Hannah. So,
I have a question.
yes.
Why are rounding up to 217 if it's like at 0.2?
Because this is the minimum, and if I round down, I'll go below the minimum. So that's why we can never round down on these, because you're looking for the sample size. If you go round down, you've just gone below your minimum. So in this case, you have to round up. So near the top of page 95 there, we're estimating. Our point estimate when we're looking for a population mean, our point estimate when we're looking for a population mean is X bar, right? Population mean, we're going to use the sample mean as our point estimate, and then we add and subtract some error, so that hasn't changed. So our X bar is still our point estimate, we're going to add and subtract some error. The difference now is instead of using Z's, we're going to use T's. It's a different table, we're going to learn a different table. And T's has something called degrees of freedom. Degrees of freedom. And degrees of freedom is defined there, just a little bit above example 5. It says that degrees of freedom is n minus 1. So it's your sample size minus 1. And then we need to find critical values. Critical values we need to find off the table when we're working with these. And we're not going to look on the normal table because it's not normal. It's a different distribution. We look at a new page. Look on page 6. Page 6. At the very top it says T distribution critical values. So you have to know when you're working with T's. Let me remind you how you know you're working with T's. When you are looking for a mean but you don't know sigma, that's when you have to use a T. If you know sigma, we use Z's like we did before the break. But now we're going to be using T's. So here's this table here. It's laid out very differently from the standard normal table, but it's actually a lot easier to read. So we're going to use this to find what they're asking for in example 1. Find the critical value. See how it says T alpha over 2 for a sample size of 10 corresponding to a 99% confidence interval. Draw my picture right here. The picture even looks normal. It just might be, flatter or taller or something. It changes based on your sample size. What was our confidence level? 95? I lost my place. 99, thank you. 0.99. So what's my alpha? Area on the outside? 0.01. Right? 1% is the area outside. So how much is in each tail? 0.01 divided by 2, or 0.005. 0.005 in here, and 0.005 in here. We're looking for the critical value, but now that we're working with T's, it's not a Z, it's a T alpha over 2. But it's still the same thing, the critical value with this much area in the tail. So now we're going to use page 6, table for T's, and we're going to find the critical value. So first off, looking across the top, page 6, across the top of table A3, which column do I want? We can either look at 2 tails or 1 tail, they'll actually be the same one, but which one do you want to look at? Which column and why? For this problem? The first one? Evelyn wants to choose the first column. Why does she want to choose that first column? I agree with her.
You got a .01.
Because we have 0.005 in one tail, and we have 0.01 in two tails. Whether either way, it's the same place. You guys okay with that? The top one says area in one tail. Our area in one tail, that's our 0.005. The second line down says, well, how much area is in two tails? Well, it happens to be 0.01. It's the same thing. See that? So we want the first column for sure. Then we need to look down the side here for the degrees of freedom, which we label as DF. Degrees of freedom,
10 minutes.
10 minus 1 in this case. Because our sample size was 10, my degrees of freedom is 9. So I know I'm in that first column. I go down to degrees of freedom 9. What do you see there? For my critical value.
3.250.
3.250. Someone need me to point at your table for you so you see where that number came from? We don't need a whole lot of critical values till we get into chapter 8. But we like to introduce them now when you first see the T's so that when you see it again in chapter 8, you're not panicking. The reason we don't need them a lot is our calculator will do all this work for us as well. Everyone okay where that number came from? All right. So then, if we want to find the confidence interval, we've got, if you look right below example 5 there, we've got almost the same thing we just did. But yes, ma'am?
I'm confused how you got that number.
So we looked on the first column because we had 0.005 in our one tail.
Yeah.
And then we went down to degrees of freedom 9. And the 9 is because degrees of freedom is n minus 1. Our n in this case was 10. The sample size was given to us as 10.
Oh, okay.
See it now?
Yeah.
Other questions? Yes.
So one tail and two tails is the same, right? So the same column.
Right, because if you have 0.05 in one tail, that's the same as 0.01 in two tails, because that's what they add up to. It always better be the same column or somebody did something wrong. All right, so everything looks the same there, and we didn't really use that formula for margin of error last time, but if you wanted to flip back and look at it on the previous page, it looked almost identical, except instead of a T, it had a Z in it, and instead of an S, it had a sigma in it. Because when you're using a Z's, you have sigma, and when you're using T's, you don't. So it has an S in it. But we're not going to use this formula because we're going to use the calculator function, which is just to do T interval. T interval. So look at the example 6. They have 106 body temperatures with a mean of 98.2 degrees and a standard deviation of 0.62. And it starts with what is the best point estimate? What's the point estimate? If you're estimating a possible X bar, thank you. We're estimating a mean. So X bar, which they gave us, what was X bar? 98.2. So we're saying that's our best guess for what it'll be for the population. Then we're going to add and subtract to get our confidence interval. But the point estimate is always either your p hat, your X bar, whatever it might be. In this case, it's the mean. Now it says construct a 95% confidence interval estimate of the mean body temperatures of all healthy humans. This right here is going to catch some of you on the exam next week. How is this different than what we were doing before the break?
That's a sample. So it would be F.
What's a sample? You're right, but what's a sample in terms of
106.
the one? Yeah, so let's talk about what they gave us maybe before we go any further. So the 106 is what in the problem?
N.
That's n. And the 98.2 I already wrote down was our X bar. We agree with that? What is the 0.62? It's the standard deviation From where?
Sample?
From the sample. That's the most smallest little minute detail. It doesn't say that for all humans, the standard deviation is 0.62. That would have been a sigma. It says this sample had a standard deviation of 0.62. So they're giving you an S. The most important little crucial details, people always come up to me and say, Jill, but I have the standard deviation. You said if I know the standard deviation, I can use the Z interval. That's not what I said.
So S stands for sample,
S stands for sample standard deviation,
samples.
and sigma stands for the population standard deviation. And that's the subtle detail. You need to know which one you have, because if you have sigma, go ahead and do Z interval. But if you only have S, you have to do a T interval. Crucial that you know the difference between S and sigma in words and symbols. So now that we know we have S, that's what tells us to use a T interval to find our confidence interval. So we're going to do a T interval. And what does it ask us for?
Data or stats.
Yeah, so we have the stats again.
That's what.
X bar, which was 98, equals 98.2. What does it ask for next? Does it write SX?
Yeah.
Remember, that's how our calculator refers to our S. It calls it SX. All the same thing it did back in chapter 3. So SX was our 0.62. N is next, probably.
Yeah.
And then the sea level. What did we get?
$98.081. And 98.319.
We agree with Ariana? What goes in the middle here? What'd you say? It's still mu. We're still estimating the population mean. We're still estimating a mean. We're just using a different calculator function because we don't know sigma now. So this means that we're 95% confident that the mean for everybody is somewhere between 98.08 and 98.3. That's my confidence interval. And then look at part C. This is the whole reason we find confidence intervals, is to answer questions like this. Does the common use of 98.6 degrees seem to be a reasonable estimate of the mean body temperature? Why not? It's outside my interval. So most of you have probably heard sometime in your life that 98.6 is a normal temperature. On average, that's what everybody's normal temperature is. According to this, that's actually a little too high. Because the mean temperature is somewhere between 98.0 and 98.3. So for part C, no, 98.6 is outside our interval. Seems to be a little high. Yes,
Can you remember again how you got the confidence interval? I really understand.
I put all that into T interval. Calculated all the work, I just typed it in. Well, you guys typed it in. Did you do T interval? Yes, Ariana?
Going back to B, I was trying to do it by hand with trying to find E.
With the formula?
Yeah, and I was trying to find the T here. So for degrees of freedom, it'd be 105, right?
I'm glad you brought that up.
And I don't see 105.
If using the table, to get your critical value, that's what she's trying to do because she wants to use the formula. She's a math nerd like me, she wants to do it both ways. She's trying to find 105 on the table and it's not there. So what you do when your number of degrees of freedom isn't here, you just pick the closest one. So in your case, you would use 100. The table's never going to be as accurate as the calculator. That'll happen quite a bit more in chapter 8. We have to use degrees of freedom equals 100 because it's closest to 105. Did you get it now, Hector?
Yep.
Okay. Okay, so what I want to do now is talk about on page 96. I don't want to do example 7, 8, and 9. I want you to read all three of them though and decide if you would do Z interval or T interval for each one of those. So I just want you to decide, do you want to do Z interval or T interval for example 7, example 8, and example 9? Be prepared to tell me why. How are we deciding if we want Z or T? What are we looking for? Population or sample standard deviation? Do you have the population standard deviation? That's the question. Do we know sigma? I couldn't hear you. Which one? 7, 8, or 9, or all three of them? We're looking at all three. Look at all three. I will tell you that there's at least one of each in there. So what about 7? These guys up here are telling me it's a T interval. Why? There's nothing in there that even talks about a standard deviation. Right? And we don't even talk about it. So I'd probably have to do a T interval for sure, because there's no standard deviation given to me. And would I do data or stats if I was doing this problem? Data, because I actually have the data. We're not going to go through and do all these right now. It's kind of time consuming. And once you know where to start, you type in everything in your calculator. What number 8? Z. You took your question back, Christiana? Why is number 8 a Z interval? Well, having a standard deviation is not enough.
Says for all.
It's which standard deviation do I have? It's a standard deviation for all such households. If it had just said the standard deviation from these 62 households, that would have been an S. But the all such households, underline that all, that's what makes it a Z interval.
So when you include all the samples, then it's one of
When they include the whole population.
the whole population.
The whole population. So when your standard deviation includes the whole population, that's our sigma. And that's when we do a Z interval. And what about 9? T again, I'm hearing. There's no sigma anywhere again.
Right.
Now, 9 and 7 are actually, and we have the data again, are pretty straightforward because there's definitely not a sigma. The hardest ones are like that one you were showing me, the first one on the lab. Let me see where that is. On page 100. I'll have you look at the first one on your lab, page 100. They're testing mercury in sushi on the number 10, page 100. And they give you a sample mean and standard deviation. So I have a standard deviation. If you read that problem, it says the sample mean is 0.719 and the standard deviation is 0.366. It does not say the population standard deviation. It just says the standard deviation from that sample. So what is the 0.366 on page 100 there? It's not the margin of error. It's a standard deviation, but which one is it?
SX.
It's the S, or the SX if you put it in your calculator. So the question is always, I have a standard deviation, is it S or is it sigma? Because if it's sigma, we're going to do a Z interval, and if it's an S, we're going to do a T interval. Look at number 36 now, right underneath it. Look at the subtle difference.
Then you use the Z.
Yeah, now they're giving you sigma on the next one down. If they're giving you a sigma, then it's a Z interval. You'll get slightly different answers for T intervals versus Z intervals. Yes, ma'am.
So for like that example, you would use the 90% confidence interval for both though?
Yeah, so they're both 98% or 90% confidence intervals. Almost everything's the same. The X bar would be the
You
same.
just change the
It's just Z interval or T interval. It's the only thing that's different. Well, and sigma and S would be different. Yeah. Questions about how to decide? One more time. Look up in the upper right-hand corner here. If you're trying to estimate the population mean, confidence interval for a mean, it tells you what to do. Yes, ma'am.
Wait, so when I got 14 on the homework, it just says, their mean weight loss was found to be 2.1. Oh wait, it's 4.8. So is there anything there as in just their story of adults?
Yes, exactly.
Okay,
From your sample.
And that says TT.
Mhm. Okay, where it says mean over here, notice what it tells you. It talks about Z interval and T interval, and it even tells you when to choose which one. You don't have to memorize which is which. You just have to know how to find it. If sigma is known, you do a Z interval. If sigma is not known, you do a T interval. You have to know what sigma means, otherwise you can't decide that, which is why I kept stressing that back in chapter 3. Okay, speaking of sigmas, our last section in 7.3 is finding confidence intervals for standard deviations. I am on page 97. Before I do anything on 97, look at the very bottom in example 2. Just look at what it says. Yeah, she's noticed the word variance in there. Example 2 should look awfully familiar. You agree example 2 looks familiar? Why does it look familiar?
It's just different. What question?
It's almost the same question we had earlier, but earlier it asked us to find a confidence interval for a mean. Now it says find a confidence interval for a variance. That's the only thing that's changed. But it's a different confidence interval because of the words there. That's the hardest part about chapter 7 is what kind of confidence interval do they want? Okay, so now that we've noticed that, we're going to go back up above and say how do we find these confidence intervals for either standard deviation or variance. There's no calculator shortcut for these, unfortunately. Scary looking formulas. Let me write it up here so I don't have to erase it. There's 2 formulas almost all the way at the bottom of the page there. looks like this. And the other one is what? The one right underneath it. What's the difference between this one and the one underneath it?
The one beneath it is.
Yeah, the one beneath it doesn't have a sigma squared. It just has a sigma. How are sigma squared and sigma related? What are they? What's sigma squared? Aha, this one is the variance. And this one is the standard deviation. Both of them for the population. And so, since this is sigma squared, if they want sigma, they just take the square root of all that. I'm not going to recopy it, you have it in your notes. But see how they're really the same formula, just because one is squared, the other one's a square root. They're scary, but we know n, we know s, we've seen those before. These, right down here, these weird x's, they're actually called chi's. They're Greek letter chi, it's like an x. And we have to look at yet another table to find the chi-squareds. Yet another one, which is what they're talking about here up at the top, the chi-squared distribution. It actually doesn't look normal. Chi-squared kind of does this, it's very skewed, and it starts at 0. You don't have any negatives. Everything's positive. The chi-squared table is on page 7. Page 7. Yes, ma'am.
Would I be able to draw on this, that river?
Yes, she wants to draw this picture on the top of page 7. Totally welcome to do that. That's what the chi-square distribution looks like. She just wants a picture of that up here. Yeah, it's kind of skewed to the right. So the first thing we're going to do is just make sure we know how to use that table and find critical values. So example 1 says find the critical values for a 99% confidence interval with a sample size of 8. Sea level's 99 and n is 8. We'll talk about that notation here in a minute. So we've had a couple different critical values already. Critical values for z's, you could do inverse norm, or use the bottom of page 5 if it's there. Critical values for t, we use that other table we just did a few minutes ago. Critical values for chi-squared come off this chi-squared formula, or chi-squared table, excuse me. So 99% means the same thing. It looks a little bit different because it's lopsided, but it's something like this where these tails are about the same size. There's different shapes, but they're about the same size in terms of the amount of area. And we want 99% in the middle. Okay there? And the reason you have to have two different chi-squareds is everything here is positive. You don't have a negative and a positive that are both the same number. Like this one might be 2 and that one might be 10, right? Because everything is up from 0. So we call this one the chi-squared on the left, and this one is the chi-squared on the right. There's one on the left and there's one on the right. So to find those, I'm going to start by looking at this one on the right. What is the area to the right of this guy? How much area is to the right? Okay, we've done like 100 of these now, guys. Making me a little nervous. Are we asleep?
Oh, 0.05?
Close. He said 0.05. 0.005, half of the 1%, right? Because 1% is on the outside. So this is 0.0, oops, my green pen just died. This area in here is 0.005. And this area over here. So really important is at the top of this page, it says that the area to the right is on this table. Not the area to the left, which has been everything else we've seen so far. So what's the area to the right? 0.005. So according to this, across the top of this page, which column do I want?
The very last one.
The very last one has the 0.005? Over here? And how do I know how far down to go? I need my degrees of freedom, which is always n minus 1, which in this case would be 7. So the last column, down to degrees of freedom 7. And what do you find? 20.278? That's this number right here, 20.278. That's my chi-squared on the right. We got silence. Anybody need me to show you where we're looking on that table? Yes, ma'am?
So, for this one, you wouldn't do 0.99 to 7, you'd do it the opposite.
I didn't hear what you said. You wouldn't do,
So you wouldn't, for this one, you wouldn't do 0.99 to 7 on this chart, you'd do the 0.005.
I don't know what 997 you're talking about.
Like, first number, for page 7, sea
Mhm.
level is 0.99. So why wouldn't you do 0.99 down to 7 on this side? Why would you do 0.005 instead?
I still don't understand your question. No, try one more time.
I just was confused because I thought you would do 0.99 to 7 on page 7. Why are we doing 0.0?
Oh, you want 0.99 at the top.
Yeah, so I'm asking
Ah.
why are we doing 0.0?
Do we have 99% of the area to the right of this guy? That's the whole reason. Notice at the top it says area to the right. So it was a 99% confidence interval, but that's not the number we're looking up at all because we always want to know what's the area to the right. Glad we finally figured out what that is because you may not have been the only one thinking that. Everyone agree that this number has 0.005 to the right?
Yeah.
What about this guy? What does he have to the right?
Same.
To the right.
Right.
A whole bunch. 0.995 is to the right?
So it would be like
0.995 is the very first column. You see that? 0.995 is the very first column. And if you go down to 7, what do we see there? 0.989? I don't have enough room here. 0.989 is the one on the left. The really good news is once you find the one on the right, the other one is always perfectly balanced on the other side of the page. So if you're on the far column here, you're on the far column here. If you happen to be one column in on this side, you're one column in on this side. They're always balanced. Hannah, did I see your hand?
I'm figuring
Oh,
that.
okay. Yes?
For like questions we do on the lab, let's say like, if you want it to the right, like it says for the right in parentheses, for example, 1, for like our homework, will it tell which one you want?
No, the table tells you it has to be the area to the right. So that's, you have to know, highlight where it says that area to the right. Because everything else we've done has been to the left. So anytime you're talking about chi-squared criticals, you've got to take the area to the right. So let's put it together in this ugly formula. We can set up one of these. Let's look at example 2, the one we just talked about. So this is similar to what we did earlier. They gave us the same information. The n is still 106. The x bar is still 98.2. But this time s equals 0.62. Why is it s? It's from your sample. It's a standard deviation from your sample. And so we want a confidence interval for the variance. We want to use this scary looking formula. Sigma squared goes in the middle. I got that part. Variance goes in the middle. Over here on the right, excuse me, I'll start over here. We'll start on the right. N minus 1 times s squared. What's n minus 1 in this case? 105. So it's 106 minus 1 times s squared divided by the chi-squared from the left. this was a different problem. Every time you do the standard deviation or variance problems, you've got to get new critical values. They won't all be the same, 'cause it depends on your sample size. This goes to Ariana's question earlier about not being able to find it. I have to draw the picture. What was the percentage, my sea level? I didn't write it down. 95. I know we're just about out of time, but give me 1 minute and we'll finish it. What's the area in each tail? 0.25? Because the 5% on the outside gets cut in half. I need to find both of these critical values. What's my degrees of freedom? 105, right? 106 minus 1. So I need to be looking on that table. And here's Ariana's question from earlier. 105's not on there, Jill. 105's not here. So we're going to go to the closest one we can find, which is the 100. So I'm down here at 100, the very bottom of the page. Which column do I want to look in? 0.025, right? That's the area to the right? Which happens to be the second one in from the end. 0.25 all the way at the bottom. This number on the right is 129.561. Now who was listening when I said the quick and easy way to find the other one?
Well, we-
See, they're balanced on either side, right? So if I'm in 3 from this side, I'm in 3 from that side, I must be looking at 0.975. You go all the way down, 74.222.
Yep.
32. So let me just write this up here. Notice the formula. This number is on the right, but look what it says in the formula. It wants the chi-squared from the left on this side. So this was the left, and this was the right. They actually get switched over here. And over here, exactly the same thing. Over the one from the right. At this point, type that all into your calculator. That will be your interval between that number and that number. It's already done. I'll do the same thing I did last time, where I'll finish writing that up for you and upload it and send you the email when I've done that, so you can make sure you got the correct answer typed into your calculator. But it's doable. You just have to find those critical values. It's the hardest part. I will see you guys on Wednesday.
So you can